Hey, this is the homework help video for Honors Math 3, Unit 9, Worksheet 3, and I'm going to start with question number 5. So we're going to start with question number 5. So for the proofs, when we have to do our proofs, we need to make sure that we pick a side, right? So whatever side we pick, that is the one that has to be complete, and then creating the other one. And so we really can pick either side. Sometimes one is a little bit easier for us to work with than the other. So this is question number 5. So I'm going to go ahead and work with the right side because it looks a little bit messier, so to speak. And so trying to simplify that is a lot easier than, maybe going the other way. So for question number 5, I'm going to start with just using some of the reciprocal identities, because I can see here that I have a bunch of secants and cosecants, but I need to end up with sine and cosine. So because I see that, then that makes me want to just use all the reciprocal definitions for these and go ahead and turn them into sine and cosine. So that's how I'm going to start. So for secant of x, I'm going to rewrite that as 1 over cosine. And then cosecant, its reciprocal is 1 over sine of x. So you really need to have these memorized, or at least in front of you. And then cosecant is 1 over sine. And then secant is 1 over cosine. And then once I have that, then I want to go ahead and multiply to simplify that. Get rid of that complex fraction. So I'm going to multiply the top and the bottom by both cosine and sine. So I'm going to multiply by cosine of x and sine of x. And that's just to clear that complex fraction. And so here it's going to distribute because we have an addition. Here it's not going to distribute, it's just going to multiply straight across, right? So there's no addition here, so it doesn't distribute, we just multiply straight across. So I'm going to distribute here across the top because of addition. So the cosines will cancel, leaving just a sine of x. And then here when I distribute, the sines will cancel, leaving just a cosine of x. And then right here, this is really just the same as 1 over sine of x cosine of x. And so this is cosine sine over 1. So then that means that both of these are going to cancel with both of these, leaving just a 1 on the bottom. And so then we're done, because now I have sine of x plus cosine of x is equal to itself. And so that's the end of that proof. Okay. And then let's go ahead and take a look at question number, let's take a look at question number 13. So we're going to look at 13 next. Okay, so again, you just pick a side, so it doesn't matter what side you pick. So for this one here, I'm going to work with the left side because turning something messy into clean is a whole lot easier than going the other way. So I want to look to see what I have. So I have a tangent squared, I have a sine squared, I have a cosine squared. And so when I look at that, so I'm going to pull out my identities here. So I'm trying to see, so I don't see anything algebraic, right? Like I can't distribute, combine like terms, that sort of thing. So, but what I do notice is that I have this sine squared plus cosine squared. So this right here. And so I know that I can replace sine squared plus cosine squared with 1. So that's what I'm going to go ahead and do. So I'm still going to have that tangent squared. But then I'm going to replace both of those terms with 1. Okay, and then I'm just going to look back at my identity sheet again. So now I have tangent squared, so I can replace that with, like, say, sine squared over cosine squared. But I also know that tangent squared plus 1 is equal to secant squared. And so the angle needs to match, right? So I have, like, the 2 here and then 1 theta here. So I need to, like, make sure I'm keeping that the same. So then it's going to be, both of those combined will just be secant squared of the same angle. So the angle needs to stay the same. And then that's it. Okay, and then let's take a look at one more here. So let's take a look at question number 22. Okay, so for question number 22, so for this one here, so they both kind of look messy as far as, you know, what we have to work with. So I think I am going to, I think I'm going to work with the left side. Because the reason I'm working with the left side is because I see something that I could do. And that's really mostly the reason I'm choosing to work with the left side there. So for this one right here, so what I'm looking at is I have like that fraction equal to that fraction, and I have that plus versus minus. So whenever I have that plus versus minus, that usually is like kind of an indicator that I should be using conjugates, and so that's like kind of the path I want to take, is I want to try to use conjugates. So I'm just going to copy down my original fraction. And then I'm going to go ahead and multiply the top and the bottom by the conjugate. So I'm going to multiply by 1 minus cosine theta. So I'm not going to distribute the top because I see that I need the 1 minus cosine squared over here, right? So I see that I need that squared. So I'm not going to distribute that. I'm just going to write it out twice. So I have 1 minus cosine theta and then times itself, so squared. So that kind of gives me that top piece, right? And then now I'm going to go ahead and distribute the bottom. So when I distribute the bottom, I'm going to do 1 times 1, and then 1 minus cosine theta, and then cosine theta times 1, and then cosine theta times itself. And so these middle terms will cancel. And then I'm going to go ahead and replace 1 with sine squared plus cosine squared. So I'm going to swap that out for sine squared plus cosine squared. And then when I do that, that's going to cancel here. So I still have 1 minus cosine squared over sine squared. And so since both the numerator and the denominator are both squared, I can rewrite it as a quantity squared. So this would just be sine theta and then quantity squared. And that's it for this video.